Now, so I think I did something the right time, which was showed us a So what this is, I think I've showed us this first one the other time, right? The series. So we understand how to generate or how to create a series. But for this,
sorry, I'm having a challenge. It's
okay,
telling me module pandas has no attribute series.
Okay, that means you use small letter. It's capital letter S. Remember I had that error the other time. So it's capital letter S. So if you change it, it should work. Now. Yeah, it should work now. So for this, what this line of code is doing is just generating random data sets of 20 rows and 7 columns. Or if I want to change it to 200, however I want to do. So let's see how that works. But it has no attribute data frame. I made a mistake there.
I think the F in the data frame is supposed to be capital. I don't know. There was a suggestion like that.
Yeah, I will check it. I'm not so sure. Let's see. Okay, yeah, you're right. So there's this thing about case sensitivity is a lot. So let's check the variable that it has created and see. I showed us our series the other time. Then let's see the difference now. And then these are data frame. Can we spot the difference from what I've explained before? So this is combination of rows and columns. Why series just deals with a single column or one, let me just say one-dimensional data set. Now that said, we have our own data. Situation where I just want to do something and then I don't want to stress myself about data sets. I can use this method to actually generate a data set, which is what I did there. But let me comment this out because I have my own data set which we have downloaded that I want to use. So let's go. Sorry. Import data set. So how do we bring that data set into this environment?
You paste the file location, a file path.
We'll do what?
Paste the file path, like import the file path.
I didn't hear you.
The file path.
Okay. Yeah, we'll import the file path. Yeah, thank you. That's what we're going to do. So there is a method to do that, which is our read CSV, which is, see this pandas is one that made that provision. So you can see pandas is actually a very, maybe one of the most important libraries if you want to work with data science in Python. So I'll create my variable, my data frame variable, and then I'll say my pandas dot. Now instead of data frame, I'll just automatically put read underscore CSV. So that data set that I downloaded, I didn't show us that part of it. It's actually a CSV file, which is comma delimited file. You understand? So the rows can see, when I over on this CSV, it actually shows something the right time about comma delimited file. So like Ayobami said, we are going to use the paths. So I think I copied the paths before we, yeah, I did. So I'll put the path inside quotes. So let's see what this brings. Now, can we see an error?
Yes.
Now, the reason why it's bringing this is I don't know how to explain it, but then this happens. I've experienced this a lot in Windows. I've not used any Mac computer, but then I've been using Windows and I've been seeing this most time. So when I do this, if I put double quote, it's something about it understanding these parts. So when I put double quote, it normally works. When I say double quote, I mean adding slash, another slash. So let's see. Can we see it? There is no error.
Yes.
So let's check our data set here. Let's view the data set that we have. Okay, something looks good. So we can see the columns we have in our data set. We have the known ID. So each client that comes or each customer that comes to apply for a loan has an ID. We have gender, we have married, we have dependents, we have education. All these columns are representing a particular attributes being used to describe each customer. Then we have the known status, which is our target when you are doing a classification task. This is what you as a data scientist is trying to predict. You understand?
Yes.
So the known status is either they have the known or they are not having the known. And we can see we have two values here, which is only yes or no. So in some cases, we might represent it with zeros and one and all of that. Then we can see their the popular area and other factors that are collected. Now, what you will notice here is, okay, maybe we should just do that. Let's check the data type of this particular data set, of the items in the data set. So if I do df dot type, you should be able to tell me an error, invalid syntax. Why would you say that? Come. Data frame has no attribute type. Most time when you just read the error, you already know what is trying to tell you. I think I'm making a mistake there. So the right command should be types, d types. Let's see. Okay, I guess that works. This Anadima has been trying to join for a long time now. He or she is not able to join. Okay, so I checked the data type. However, I didn't print it anywhere or store it anywhere. So let me just put it in a variable and call that one types so that we can be able to visualize what is inside it. Now I have my types here. Please, can we all see this? For the known ID, it's an object type. For the gender, it's objects. This is object, this is object. Then we have integer type, which is the applicant income. Then we have the float type, which is the co-applicant income. Then floats. I just did it so I will know how the type of data set that is actually on this table or on this data that we have generated. Now I'm trying to look for something here. I don't know if we can see it. Yeah. Do we notice something here? This particular one?
Yes.
Yeah, it's called missing values. You see, some columns have missing values. That means the values were not supplied, which is something that is applicable or even common in real life. Because in real world, like example that I cited the other time, I'm just taking stock of my cocoa business. There are days where the customer will just say, okay, right, you say, what's your name? Full name, full name. And then someone say, just take my first name. What do you want to use my second name to do, or something like that? So in the column where column where the second name supposed to be, nothing will be put there. So that's where missing data used to come from. So there are different real life cases where you can have missing data. If you are taking symptoms of malaria and then someone does not have stomach ache, and then some other people have stomach ache, for that person that does not have stomach ache, for that particular column, that person's data is missing. So there are cases, genuine cases where you can have missing data. And then we'll see how we address that as we move on, because you cannot do much or get high prediction or accuracy with that kind of data set. So we have to address the missing, the set of data that are missing, even in our analysis, before we can go on. So another thing that we want to do now is coming. So there are different things you can actually do, but let me do this. What this will do is just, I just want to see a sample of what is in the data set. So if I just put print, which there is no need because I've already seen it in this div, but I'm just trying to show you that there is a method that exists like this. You can see what it brought out for me. So automatically to bring the first 5 items, you understand, or 5 rows rather, and then to give me the sample of the data that are there. So if I want to pass the value, I'm saying, oh, I just want to see the sample of the first 10 people that are on this list. Then I'll see it, I'll check, okay, most of them are maybe I can go on. Then another one you can do is tail. When you're doing tail is just an opposite of head. So what tail will do is to take the data set from the bottommost part and then pick the last 10. Unlike that one, this particular one that picks the first 10. So let's see how that runs. Can we see it? Can we, just by checking the number here, you will notice what it actually printed. So this one prints the last 10 values. This prints the first 10 values. So that's just that one. I'm just trying to show us what that one can do. Now, what if we want to get the summary of the data sets? So what I just have to do is maybe let me assign a variable and call it summary is equal to then my data set df dot describe. And I want to confirm that I'm recording this. All right. So what this is supposed to do is to give us a brief description of the data set. So we can see it will bring something like the counts, the mean, the standard deviation for each of the columns that we have. It's going to bring that value for us. Now, even from this description, we could see in counts, realize that the entire record actually supposed to be 614. So we'll see some. This having 592 means there are some missing data here. This also have 600. So from here you can tell, you can make some assumptions, not even assumption. You can see fact that yes, there is missing data under this particular column, credit history. Column known amount also have missing data and all. So there are other information you can find out here. These are mostly statistical informations that can be interpreted. The mean, the quarters, and all of that. So they have their own meanings and functions. So that's just, by the way, what that one is doing. Now let's move on to getting a, how will I put it now? What I call exploratory analysis. We want to explore the data set further. Exploratory analysis. So like I said, this will just allow you to see, to gain more understanding of what this data is about. You want to see how the data looks, the type of the data, all of that. So this is still the same set of libraries that we are using for this purpose as well. So under that, let me first check the numeric distributions. Now in this data set,
hello ma, sorry, can I ask you a question?
Yeah,
so is it that it's only pandas we've been using all this while? We've not used numpy and matplotlib?
Okay, we've been using pandas mostly, but at this point, when I generated random number, we used it here. You can see NP here.
Yes.
So we use NPA, and when I explain what NumPy is, I said it's basically for all those mathematical, anything deep mathematics like algebra and all of that I can think of. We are thinking of NumPy library. You understand, to be able to access them in Python.
Okay.
Yeah. So can we move on?
Yes. Thank you.
So this kind of analysis that I want to perform now, which is exploratory analysis, it allows you to see, like, to kind of explore the data set further, to see the nature, to see the structure or the composition of it, if that word will be permitted. So it helps us to know if there is need for data preparation. So it is from here you'll be able to tell, okay, I will need to do something more about this data set and all. So let's move on. So I was trying to say something before I even asked the question. So I was saying, when we check the data type the other time, you could see that there are different data types. So there are a few ones there that are numbers. The number data sets, the number columns, can we list them? Those ones, I think that they are numbers here. We've talked something about data type when we first introduced ourselves to Python. So which of these columns do you think are numeric columns? That means the
applicant
number.
income.
Okay, applicant income.
Co-applicant income.
Okay.
Loan amount.
Okay.
Loan amount term and credit history.
Okay. So there's no other one. Yeah, you are very right. Because when we talk about data types, all these fall under numbers. So what I want to do now is to do some kind of analysis on the numeric columns. We want to see some kind of distribution. How is it distributed? Is it evenly distributed? Is it scattered? Such questions. So to do that, I will use this code. Now, the reason why we have to do that first part that we did the last 2 days is because of something like this. If you have noticed, mostly our syntax is still the same. Or is there any change in syntax?
No.
So we have to, that was what makes the first 2 classes important, because now you see I'm trying to use something we have used before now, this indexing. I'm using it here again. So to access each column in this data set, to access each of these columns, this is what you do. We just put the name of the column inside here. So let's say I want to access the loan amount, which I believe is part of the numeric data columns, right? So I want to access this. What I want to do is to just plot. I just want to plot an histogram. And what the histogram will show me is to show me the distribution of this particular column. Now, if I run this, can we see something here? So it's telling me that my picture or the figure I've plotted is inside plots. Are we all seeing this?
Yes.
So this is the plot. This is the distribution for our loan amount column. So what can we deduce? Anyone that is familiar with statistics or data or something, what can you deduce from this kind of data? What are you seeing?
the amount of loan they've taken over time.
Okay. The amount of loan they've taken over time, which is the particular specific data that we actually plotted on this graph.
Yeah.
Okay. Thank you. So what other thing can you deduce? It's amount of loan, right? But if I'm the one that gave you the data and you are supposed to interpret what this is to me, what are you seeing?
Like a lot of people are taking loans between 100 and 200.
Thank you very much. A lot of people are taking loan in between this 100 and 200. So we can see the rise, you can see the very much increase in number of people that takes. Now, by the way, this column is for frequency, and this other one is your loan amount. You understand?
Okay.
So another thing that I think we can deduce from here is we can see that, okay, these people here from 0 to maybe 200, like Ellen said, their loan, yeah, a lot of people are there, but then they are taking lesser loan. Can we notice that?
Yeah.
Yeah, their loan is just in between somewhere around 200. Then drastically it's dropped when you get to 300. So this could even tell me that most people that have been coming to this particular company, the highest percentage of people takes this lesser amount. But then there are some people who, I don't know what kind of business they are doing, but the kind of loan they require, we can see, you see some already reaching, and then some far away to 700, maybe that's $700. I don't know what that is for. Let's imagine as $700 or $700 million. So someone is taking this loan. Now, what the implication of this on us or on our analysis as a data scientist is, it's going to create a kind of I won't call it bias now, but it's going to create a kind of how will I put it? It's an extreme. This is an extreme value. It's at the other extreme. Do we understand? We are having the distribution. Everything is equally distributed around here. Then it's not. But when we got here, we can see, oh, it's scattered. Now this one is just taking this. This one is taking that. This one is taking this. So this kind of data can affect our analysis on the long run. So it tells us something that there's something we have to do. Mostly they are called outliers. So outliers is, for example, I gather 20 black kids, and I want to make a judgment. Okay, let's say example, I want to test an algorithm that determines faces of people. You understand? Is able to, if a facial recognition algorithm is what I want to write, then I gather 20 black kids, like from Africa, and then I now put two white kids here. You understand? So my algorithm is going to learn something, but however, it's not going to be accurate because there's going to be a kind of, let's say, bias now, because there are outliers. In that case, the two kids that I put that are not the same color with the other 20 make it difficult for the algorithm to make good predictions because it will have sufficiently learned how to recognize the black faces, and then by the time you get to the white, it might just not be doing its best there. So this tells us that there is an extreme value. We have extreme values here, or we call them outliers. So there's something we have to do about that too. So let's check the one for another numeric data set. Let's see if it's the same thing we have for that. Which other numeric data set do we have there? I think we also have applicant known. We also have applicant known. Are we getting it?
Yes.
Okay. Is it known or income now? Applicant income. So let's see the graph for this one also. Okay. What can we deduce from this one? Like I said earlier, what this is just doing is plotting the frequency against the particular amounts. What can we deduce? Now, the reason why I'm asking these questions is, how will I put it? The people will give you data, but they'll give you the data as it is. The way we downloaded data the other time. Some, you will even be the one to input their record for them and stuff. So you have to be able to tell, even before you do analysis, be able to do some exploration of the data set and be able to tell where this is the nature of your data. Because sometimes you see some data and you think, well, it's simple work I'm going to do on it. But at the end of the day, you find out that you're spending night and day trying to make it work or get high accuracy. And that's because you have made the mistake of doing all these ones you are doing now. You didn't check the distribution of the data set, you didn't check the distribution of each column and stuff. So what can we deduce from this? Just the same way you answered the last one. So I think, okay, that's Ayobami.
No, that's been Emmanuel.
I think it's Emmanuel. Sorry.
Okay, I think, okay, this one is coming from applicant income. So it's showing that people with income of over 10,000 are collecting higher amount of loan, or people between the range of 0 to 10,000. People with income between the range of $0 to $10,000 are collecting higher income. Are collecting higher amounts of loan.
Okay. Okay. So any other thing? Thank you very much, Mane. Is there any other thing we can deduce? Does that even, in real life, does that explain anything? Why would people with this kind of income be the ones collecting this? Like they are always coming to say they want to collect loan. Now, all these questions I'm asking us is actually very important because you are not just getting data, you have to be able to interpret or tell a story around your data. Because at the end of the day, what you want to suggest is a decision. You want to use it to make a decision. So, like Emmanuel said, obviously we can see that these people that are getting this salary or this income, they are the ones that turn up for loan the most. And in real life, it can just be where someone with lower salary income will have more need, so their expense is going to be more than their income. Does that make sense?
Yes.
So at the end of the month, they probably are in debt and then looking for a way to get more income so that it can match up with their expense or other needs that they have to fulfill. So this actually explains something. Are you seeing what I'm trying to like deduce from just the graph like that? So
Yes.
so it explains something. But then, like we noticed from the other one too, we still have an issue here too. You can see the outliers. See these guys. These guys that have plenty money. Can we see them? They only come once in a while to collect loan.
Yeah.
By the time we check this particular one the other time, they collect loan and the amount they collect is okay. They are not the ones here. Sorry. Yeah, the amount they collect is kind of lower than other people that collected, or the other ones with lesser salary and stuff. So we can do that for different numeric tables, just for us to explore what exactly is it, how is it distributed. So we can see that in this case, these are scattered. They are scattered. They are not in one place. I don't know, maybe if we try another one, we might see one that is well packed or evenly, perfectly and evenly distributed. Let's see another numeric variable that is there. We've done loan format, we've done American. Let's see for loan amount term, or maybe credit history. Okay, just to avoid wasting of time, you can just try that on your own. Do this for all the numeric data set columns that you have on your own laptop, and then transport the difference. What can you deduce? You can just see the way we're trying to find out something. It's the same way you try to find out something or ask questions around your data, and then be able to make a conclusion. Now there are other ways to actually get this kind of distribution also. There are other ways. You can use a box plot. You can use a box plot which is also very much useful for this purpose. So let's see the difference between how a box plot will look, and then how the one plotted the other time was histogram, right? So let's see how
Yes.
a block. Thank you.
Hallelujah. Awo Saruta.
Yeah, I have to note that person. So using box plot to achieve the same purpose, you check the distribution of this numeric data set. The code for that is just to do your box plots into bracket. Then the column now. What is the column name? I want to check for this same one. I don't know why it's joining the histogram with that. It's not supposed to be doing that. I don't know why that is happening. Let me comment out this, which I don't think is supposed to be a challenge. Okay. So when I comment that one out, it was not showing. Now this is a box plot. So it's doing the same work. It's showing us the distribution also. So we'll see around this place, we see like, okay, everybody seems to be on the same page. Then all of a sudden, up here, we are seeing some guys standing afar off and saying, no, we will have our money. So this and that. The amount we want is just a very little amount. Or sorry, the amount we want is something very much. So there are some guys that collect that much of amount and stuff. So you can see it's the same thing that this is actually depicting. Now I could want to, it's very possible that I want to compare the loan amount based on their education. You understand? I want to be able to check, okay, what's the nature? How do they, if this person is educated, does he have anything to do? Is education contributing to the way they collect loan? So that kind of question. So how do I answer that? I'll just say my colon is equal to, okay. Sorry, let me check for this. Let me check for applicant income and by education. So let's see if their education determines what kind of income they get, or their income is based on their education. So there is actually a column called education, so I'm not making this up. Okay, can we notice anything?
Yes.
Okay, so what can you notice?
Okay. The people who are graduates are actually the ones who collect most loans. Oh, is it not graduate?